Yes, so let's get started. Today's March Customer Insights webinar, we're having case Stavanger Hospital, and we have with us Henrik, Eirik, and Morten, who will be presenting today. I'm your host, Maya. As always, I'm the Marketing Communication Manager here at Solibri, and we'll be happy to be here with you today. Our webinar agenda, we will start today with an introduction to the project with Henrik, and then we will move on to checking and quality assurance, followed by a demo with Eirik. And then we will talk more about Autorun with Morten, and we will move on to BCF Live Connector, followed by a demo with Henrik. And then we will have more time for your questions. So anytime when you feel that you have a question, please write it in the chat or in the question box that you can see. And it will be really great if you can identify if your question is for Eirik regarding checking and quality assurance, or for Morten regarding Autorun, or for Henrik regarding BCF Live Connector. It will help us a lot in answering your question the best way possible. And if you have questions for Solibri, don't worry, send it in the chat and I will send you the answer later on privately to your own email. You don't have to write your email, just write us the questions and I will send you the answer to your email. But just mention that your question is for regarding Solibri in general. And we have one question for you so that we would know our audience a bit better. We will get to know you. And here it is. Okay, you cannot see it, just a second. All right, so what is your field of expertise in the construction project? Please choose one of these answers. I see that there's no voting happening, so we're facing some technical problem, but I can see that most of us are sending me answers regarding architecture. But let me try to share it again. Please let me know if you can vote now. Nope. Okay. So, all right, then maybe we can move on since we have three great presenters, and I'm sure you cannot wait to hear from them. So let's start with an introduction. Without further ado, I'm giving you the floor, Henrik.
All right, should I start then? Or yeah, I can introduce myself. My name is Eirik Soland Thu, and I work as an engineer in COWI. And I work mainly with piping and ventilation. But to be honest, what's my main interest is how we can use all the information we have available today and all the information we have in our models to work smarter and more efficiently and communicate better in projects. So essentially, how can we take advantage of all these new possibilities that comes with BIM modeling to perform better projects, really? So that's my take.
Yeah, Hey, I'm Morten. I also work in COWI as part of the planning team for this hospital. I mostly work with piping. I'm also currently a BIM manager for the mechanical discipline. And today I will present Solibri Autorun for you and give you a brief overview showing you how we use Autorun in this project.
Yeah, hi, I'm Henrik. I'm part of the digital coordination team from the building owner at the new Stavanger Hospital. And I will present a little bit about the BCF, how we use BCF Live Connector in this project, and also a little bit about the project in general. The project has a budget of 1.1 billion euro, approximately. It's a 125,000 square meter hospital, which started the building process in 2019, and it will be in use in 2024. All somatic bed patients and emergency patients, as well as necessary supported functions, are moved from the old hospital into this new one. There will be single room with bathroom for all everyone on the hospital. And there's approximately 640 bedrooms planned. Here's a drone picture of the building site. How far we come by now. In the project we have a very structured BIM model, and we have a lot of properties with a high degree of data integrity. That helps us a lot with automating a lot of the processes in the project. We can filter all objects out on certain parameters. So this is an example of data integrity for the control area. So the whole building is split into control areas, which is part of a floor. So here we can see all the objects which is inside of one control area. The BIM model in the project have a higher rank than the 2D drawings, and the design team they collaborate through BCF. And the project has more than 3 million objects. So you see here, there's a BIM model with all the buildings in the project. It's a huge project. It's also a high complexity due to more than 300 contracts, where 150 of them are affecting the construction, and there's another 150 for medical equipment. Here's a picture to illustrate some of the complexity, and this is before the electrician got started. We also use laser scanning to check deviations for openings, etc. And here you can see what looks like the concrete floor here is the scan, and the green piping here, that's the BIM model. And as you can see here, there's deviation between where the opening for the pipe is placed. So therefore we can check these deviations before we mount the pipes at place. Another example is for installations, where you can see the ventilation channel here, which is modeled in blue, and the way it's placed in the building site is here in red. And here on the right side, you can see the picture of the pipe. So therefore, we can easily check whether things is placed due to the model or not. So, Eirik, you will continue.
Thank you for the presentation, Henrik. I will continue with I will start with some general comments about the things we're going to discuss today and how they all tie together. So I think you can see my screen now. So first of all, like you probably understood, this is an ongoing project. So many of the things that we will go through today is things that have been developed throughout the project and implemented on the way, so to say. So we are still learning, and it can still be even better. But I think like the key the key things to take away from this, or the main points, will be of interest to many of you, hopefully. So what we have seen is that, especially in projects like this, where I would call it high-level BIM projects, where the ambitions are very high with regards to the model, it's very important to have efficient workflows. So what we have struggled a little bit with, I would say, is that we had some workflows that probably worked in the past, but in these kind of projects, they can easily create a lot of friction, so to say. So we are used to having our design models that are up to date at all the time, but it's important that the rest of the workflow also reflects this. So the whole team needs to work on updated information in all parts of the workflow, not necessarily just in the design models. So that's why we have made a system to update the IFCs and Solibri files with checking results and distribute them to the organization. And we also have a system for handling all the model issues and communication in the project. So it's not that long ago that every team member had to manually update all the Solibri files and run checks if they wanted to use that. But on a small project, that might be okay. But when the project becomes of a certain size and the files, they grow in size as well, it could take easily many hours just to update the Solibri files. Then, of course, what happens is that it doesn't get updated as often as it probably should. And if people work on outdated files, they start to communicate issues on outdated information. So that's not good, right? So that's why this is so important. And also, like Henrik will talk more about in a bit as well, we also have a BCF server and use the BCF Live Connector to communicate. But it's not that long ago that we used to send BCF files back and forth, and they end up in an email, or maybe they got stored on a server. They exist in multiple locations, and quite often they don't get updated as well. So that's of course also a problem for the whole execution of the project. So that's why it's so important to focus on the whole workflow. So I will continue now on my main bit, which is how we do the quality assurance in Solibri, and I will show our setup there. But first I want to just take you through some of the like general thoughts around how we have set it up. So we wanted to have a setup that worked on the whole project, so it was easy to maintain, easy to update, and easy to add new rules, for example. And we have that now. We have one rule set that works on the entire project, even though each building is essentially its own project in a way. It's separate Revit files, separate Solibri files, and also a separate setup in BimTrack as we use. And to achieve this, it's important to look at how the rules are set up and generalize it so that it works on all the buildings and the whole project. Another thing that was really important is, or it was to make it as independent of object parameters as possible, because that is, as probably many of you have experienced, that can be quite challenging to achieve, and it can also be a huge limitation when you try to make checks in yeah. So like Henrik mentioned, it's a high level of data integrity, and on the construction site they use these models instead of drawings, and they also depend heavily on certain parameters to be correct. But from our side in COWI as designers, we cannot we cannot verify the parameters if all our checks or all our schedules in Revit, they depend on parameters. So that's sort of a contradiction there. But of course, it's challenging to create or try to create standardized checks. when there is no universal standard. So it can be challenging, and the more detailed the checks become, the more challenging it can get. But I would like to challenge everyone that's listening in today. So if you have previously made some checks, or if you are going to make some, just try to make it first, and then ask yourself if you can achieve the same result by changing the rules and make it more generalized, because I think that's a good practice. But in our setup, what I will show you in just a second is how it's set up, and or the key to our setup really, that is that we have a dedicated model. We call it the control area model, and it's just a model with no physical objects. It's just like geometrical shapes that divides the project into smaller pieces. And all these pieces have a unique name, and they have also a unique delivery dates, so they follow the plan, etc. And this setup makes it very easy to extract all the objects within a specific area, and it's completely independent on any of the object parameters themselves. So it doesn't matter if the parameter exists, if it's missing, if it's wrong or right, you will still get all the objects. So that's really important. And probably the most interesting thing is how you can use these results and combine it with other kinds of check to filter out the results. So basically you can filter out the results of any checks based on this first step. And this of course enables us to focus specifically on a certain area or the next delivery, and do a variety of checks. So I think now I will just switch over to the live demonstration. So this is one of the buildings we have in our project. For this demonstration, I have removed some of the files, so hopefully it works for the demonstration at least. I thought first we can just have a look at how this control area model looks. So as you can see, it just divides basically the whole model into smaller segments. So one floor is typically 2 horizontal areas. So this is what goes into this checking here on the right side. So on this top bit here, you can see it's divided into levels. So every level have listed all the control areas for that level. And this whole setup works, like I mentioned, on all the buildings, not only this particular building. And how exactly does that work? Well, first of all, if we look at this particular control area, we can see that it has a name or a number here. And this in this model, it contains, or the first bit before the punctuation, that is only relevant for this particular building. But the last bit is the bit that is sort of generalized, and that is the same system for all the buildings. So by using only that bit in these checks, you have a setup that works on all the different buildings. That could be also completely different projects if you have a system for it. So that's with that said, all the things you can see here, they are just very simple standard collision checks between, on the one side, this control area model, and on the other side, all the models we want to extract objects from. So the last part, that was something that gave us a bit of a headache, because you want to be able to choose on each building which models we want to include in the checks. But at the same time, you don't want to have to go into the rule set and change the rules for each building. So you want to keep that one rule set, so it's easy to maintain. And what kind of solved that puzzle for us was, as you can see here, was to create a new category here. So that is something we have set up for in all the buildings, set it up, and it's named the same thing, and that's enough. And then you can just add individually in all the Solibri files for different buildings, you can add the models you want to choose. So then it doesn't matter what the name of the file is or anything, as long as it's included in this particular category, it will automatically be included in these collision controls. So this whole setup here with these checks, they only depend on one parameter, which is the number or the name of this control area. It contains, or it depends on the geometry of this control area, and it depends on the existence of this category, really. So enough talk. So I want to show you how it works. Here you can choose one, you can choose many, or you can choose a whole floor. It's very flexible. And if I just select the results from this check, I get all the objects within these two control areas. The gray ones here, they don't exist in this particular building, but they exist in the other buildings. And like I said, none of the object parameters here, it doesn't matter if they are right or wrong, they will be included in these results. So this step alone is something we have used a lot to verify the parameters, for instance. And we have used information takeoff, and we have actually done quite a lot of checking in Excel to do that. But you can also do it to do material takeoffs, but then you have to make sure to split objects between the control areas in the model. But the most important or most interesting thing for you guys, I think, is to see how it works if you want to combine it with other kinds of checks. So, for instance, here we have a setup with different kinds of checks. This particular check is a check between all ventilation and piping against all the other, it's called our technical systems that are included here. So basically electrical and other systems, so to say. So if I want to just get all the collisions within these two control areas, I select this check and I go here into the results and I filter the results with the selection basket that we, by selecting this first step, they are put into the selection basket. So if we filter with the selection basket, you can see that all the results are filtered out. This one is very general. It takes all the collisions. So even this is quite a lot of collisions here. Personally, I use this a lot just to walk around in the model. I identify the collisions and then I go back to Revit or whatever and fix the issue there. But even more interesting is that you can also split it up. So if I only want to look at collisions between ventilation and other technical systems within these two control areas, I can go down here and I can select this check, which is specified that only shows the ventilation. So that makes it really easy to just focus on what's important to you. So if you work with the ventilation, you can use this check and you don't need to see anything else. So in this setup, there is not a lot of exceptions really, because at the same time you want to be able to trust what you see. You don't want to be asking questions, is it showing everything that you expect it to, etc. So there's just a few exceptions, but apart from that, it's just a collision between this one. Since we have a huge project and ventilation is in a separate file, it's just the ventilation file here, and it checks for collision against the other files. And it's also based on the same category, so that it works in the same way. If you include files in the category, it will also be included in these checks. And like I said, you can basically combine this first step with any other check. So this was like typical collision checks, but it could also be other types of check. First, before I go further, I just want to mention, if like we have one file that we kind of, all the systems that doesn't have a unique file end up, and then of course you have to sort of, if you want the same sort of setup, you have to base it on some kind of parameters. And this is following the Norwegian numbering system, so that's probably a bit different in your country, but try to make it as general as possible, and then you can make the same sort of setup here. So here you can easily filter out all heating or all cooling within the same control areas. But as I said, it also works with any other kinds of check. So if I want to check for all collisions between piping and ventilation and columns and walls, all I have to do is select these like that, and then I get all these collisions. As before, if I just want the ventilations collisions, I select this, and then I select the columns and walls, and I only get these. And of course, I guess Solibri, the intention with this setup was to go through and accept and reject each collision. We don't actually use that because we actually clear out all the results every night, and then we add the rule sets again. And this has two purposes. First of all, our models are huge, so we want to clear out every unnecessary information that is just kept. So we clear out all the results, but at the same time, we also add the rule sets again each night. That means that if we make a change one night, it will be automatically included the next time it runs. So this is something that Morten will talk more about in a bit. But both these two examples were standard collision checks. It's very useful, and it's something that we use a lot, and we update using Autorun, and we distribute to all the project members. So it's not something that everyone has to run manually. But it also works with other kinds of checks. So just to take one last example here, you can also use it, for instance, with a check like this, where we made a check to see if the fire hose cabinets are too close to the doors, because we don't want the doors to block the fire hose cabinets. So if you just want to see those results within these control areas, you select this check and filter with selection baskets. But if I don't filter and select again, you can see you also get the results from all the other control areas that have that get results from the check. So I think that was basically what I was planning to say. So then it's up to Morten to talk a bit further about how our setup is in Solibri Autorun.
Thank you so much, Eirik. I am giving the floor to you, Morten.
All right, thank you very much. Yeah, now you can see my presentation. Very good. All right, so now I'm going to take you through Solibri Autorun and how we use it on this project. So Autorun is a tool in Solibri that allows us to automate several sequential tasks. Anyone with a Solibri Office license and a fairly updated Solibri version installed can use this. So what is the motivation behind using Autorun? By using Autorun, you can save time by running tasks in the background, maybe of both your desktop and your mind. You can save computing resources by running it outside of office hours. You can save your colleagues from all having to do the same boring tasks by processing in a central hub and distributing the result files to the project members. And you can use you can automate creation of issues based on the checking results and the status set on each result, as if they are rejected or accepted, and so on. Also, you can save yourself from being bored to death if you don't like clicking the same buttons every day. So what can Autorun be used for? We can update IFC files after you've made changes and exported a new IFC or gotten updated IFCs from other disciplines or external collaborators. You can import new IFC files when you need to add more IFCs to your model, which we can safely assume will happen in every project. You can also use that feature when you're putting together the federated Solibri model for the very first time. You can import rule sets and classifications and run the enabled rule sets in the model. So if you have some rule sets in the model that you don't want to run, you can just disable them and save the model before Autorun. And also, what we can save a rule set with some enabled and some disabled rules. And then when you load the rule sets into the Solibri model, the enabled or disabled status of each rule will be preserved. Further, you can create issues based on the checking results, and you can create presentations based on the issues that are not accepted. And then newly added, you can also do information takeoff with an automatic Excel export to the disk. All right, now, how do we use Autorun on the Stavanger Hospital project? Well, first I'll take you to some prerequisites that we have. We have an automated nightly Revit routine, performing some tasks on the Revit models, which includes exporting new IFC files. As Eirik mentioned, the models are huge, which is why we have split the project into 5 federated Solibri models, 1 for each of the 5 buildings you can see to the right here. In addition, the mechanical Revit models have also been split into sub-disciplines, such as sanitary, ventilation, sprinklers, and so on, as Eirik also mentioned. We have centralized processing running on a server in Denmark, which is geographically close to where all these IFCs files are stored. On the server, we run 2 parallel Solibri sessions. One is running the 2 buildings in the west, the red and green ones, and the other one is running the 3 buildings to the east in blue, purple, and yellow. After processing, the newly saved Solibri models are distributed to the team members using OneDrive. So in the morning at 7 a.m., the Solibri Autorun starts. I'll get a little bit back to how it starts later. So first we open the model for one building, we update the IFCs, and then the model is saved. It's then distributed to everyone, to all the team members using OneDrive. Then the same is done to the other models in that parallel before we start the part on the right. Here, the model we saved earlier is open, the rule sets are added and the checks run before it is saved and closed and then distributed again. This time it's given a different name with checking results. And so the end result is this. The IFCs are updated, the models are checked, and all the users have to do is to open the models locally on their computers. Because we've set the OneDrive sync setting on the Solibri models to always keep on this device, it will automatically download when a new model version is available, so they don't have to wait for it to download when they want to open one of them. The system turned out to be especially important during the home office periods because updating one IFC manually could easily take 1 hour due to the slow transfer speed on the VPN we had to use. All right, now I'm gonna get a little bit back to how Autorun starts. So what you see here is the user interface of COWI Assistance, a part of COWI Tools, which is a piece of software that we have developed in COWI. This thing can do a bunch of cool stuff, but it was primarily developed to run tasks in Revit, and we use it to do the nightly routine I mentioned earlier, the one that includes exporting the new IFC files. The part of it we use here can, for example, be done using the Windows Task Scheduler. I've also been told there's a lot of very good open source options available for those few out there who aren't totally in love with the Windows Task Scheduler. It would then simply run very simple batch files used for launching Solibri Autorun and copying the files from a local disk to the server on the server to the OneDrive folder. This setup shows the parallel running buildings 11, 21, and 22, the ones in the east in the picture I showed earlier. First, the updating, then the copying, then the checking, and then the copying again. this has a trigger option, and it will start every day at 7 a.m. and then run through all of them, starting the next one after finishing the current task. The paths you can see to the right here is the path to the Solibri executable and the path to the XML file, which in this case specifies which Solibri model to open, which IFCs to update, and where to save it. All right, that was pretty much everything I was planning to show you. Hopefully Maya has or will share some links with you that that shows Autorun in a little more detail, and an example of an XML file, which is really very easy to set up when using that example.
Thank you, Morten.
Right.
I do have your links, and I will be sharing it with our website page. The link to it will be shared with our attendees later on after we finish the webinar. Thank you so much.
Right,
now
perfect.
we're moving to Henrik.
Yes. I'll be talking a bit about the BCF Live Connector in Solibri and how we use it in this project. In the beginning of the project, the BCF files were sent back and forth. As Eirik mentioned, mails, issues, and they were placed on many destinations, and it was a problem to know which one were solved, which were open, etc. So we needed to find a master solution, a BCF server, to store all the issues. And since the design team collaborate through BCF, we have for now more than 12,000 issues in the projects. So for the past 2 years, that's approximately 30 a day. There's more than 200 users, and the BCF server allows to have seamless collaboration across software like Solibri and BimTrack and Revit and Tekla. So no matter which of these programs you will sync your issues to, you will find the correct and updated information. We had some main challenges when we were setting up the project. One of them was that the BCF format, it doesn't support custom parameters. And also that same parameters have different names across the software. And we have trouble keeping control of more than 12,000 issues. And also that the software, all the softwares also had trouble handling those large amount of issues. We also have a large amount of IFC data, which gives us some challenges in all the softwares. And also the property types in the BCF format, where some of them are free text values and fixed values. Some of the parameters allow one value and some other allow multiple values. So what we did is that we made one project in the BCF connector, BCF server, BimTrack per building to split up the number of issues. And we also had to redefine the parameter types, which allows us to use very narrow filters to show only a few BCF issues. Here's a table that we sent out to the design team, which shows us the name of the parameters in different softwares and how we use it in the project. For instance, we use the parameter called phase in BimTrack, which is called milestone and stage in Solibri. And we use it as the responsible discipline. And that's because this one only allows one single value. And the discipline parameter or the label in Solibri, we use it for the control areas because this value allows us, this parameter allows us multiple values. And we needed to have multiple control areas attached to the issues. So this way we kind of mapped the the parameters we use in this project to the parameters used in the parameter names in the BCF format. I'm going to show you some of this live. In BimTrack, we are allowed to define all the values that are used in the project, which is good because then we have high integrity of the data, because we can decide which parameters the designers are supposed to use, compared if they use free text fields and free text values. It's more difficult to filter out when more than 200 users are trying to do the same thing. So in here we can edit and add values to the different parameters, and we can also add new categories of custom tags. But the custom tags don't follow the BCF format, so they won't be shown in Solibri, but we still use them in BimTrack. I will come back to that. Here is from Solibri, the BCF Live Connector. We have tried to be very clear with all the designers that it's extremely important to add all parameters. So we had a set of parameters that everyone needed to mandatory parameters, and that's because if we don't have mandatory parameters, the filterings will be difficult, and you will have too many issues in your filter, which will take a lot of time for the different software like Solibri to synchronize. We said everyone need to add a status, and all issues need to have type. Everyone need to have one responsible discipline, which is called stage here in Solibri. Every task need to be assigned to someone, and we also need to add which control area this issue is about. And when you have all these mandatory parameters, it's more easy to filter out only those issues that you're interested in. So now when I add that filter, Solibri will start importing 5 issues at a time. And for this particular filter, we will get 11 issues. And the more issues you get, the heavier it will be for the software to work. So that's why it's important to keep the filters low. This allows much better filtering options. We'll do this way, and in Solibri, you can see here through the issues that it's possible to search for parameters. You can add several parameters if you want in your search. And here you can change the issues. I'll show you also how we used Solibri for what we call the multidiscipline model control. So before for each control area, we have one multidiscipline model control, and one control area is approximately 1,000 square meters. And what's happening is that all the disciplines, they prepare issues before the meeting, and they all tag them with the status TMK, which is Norwegian for multidiscipline model control. And after they all synchronize to BimTrack, the meeting responsible person will go into BimTrack and search for the control area and for the tag TMK, and he will add the custom tag TMK. And that allows us afterwards to change the status from TMK to other statuses, like closed, and we will still be available to search for TMKs from the custom tag other tags. So here I search for control area 0202 in building 71. And here you can see which issues were a part of the multidiscipline control and which are closed and which are still open. Yeah. That's about it, Maya. You can take the question part.
Thank you so much, Henrik, Eirik, and Morten. This was a very informative presentation. So let's move on to the questions part. We've had some very interesting questions. So I will start by choosing some of these questions. Don't worry if your questions were not answered, we will answer them quickly later on. But first of all, question to Henrik. Now that we're talking about BCF sync functions, if I don't have live BCF server like BimTracker, how do I sync these BCF more efficiently? Right now they're doing it manually and it's causing some problems.
To be able to use the BCF Live Connector and to be able to synchronize, you need to have a BCF server. That's the main thing. So you need to have a BCF server to be available to use the Live Connector. But Solibri's BCF Live Connector has integration with multiple BCF servers, so it's not necessarily BimTrack you need to use.
Okay. Thank you, Henrik. There's another question for Morten. Can you use Power Automate to build Autorun?
Power Automate. I'm not sure. Do you know, Eirik?
Not that I know,
don't think so.
But it seems like they are developing the Power Automate platform from day to day almost, so maybe. But I don't think so at the moment. Not that I'm aware of, at least.
Okay, we can check it later on and send you the answer. There is a question for Eirik. Is it possible to see the parameters of the rule of the area zone to better understand how it works?
Yeah. Then you have to share my screen, I guess. It's very simple. It's just the name of the control area. But if you use equal to, are you sharing my screen? Yeah?
Yes, just a second.
If you use equal, then you're sort of, then it's not very general. So instead of using equal, I would recommend always to use contains. So you use contains and you try to identify the part of the parameter that is the general part. So use that part. And then you can sort of make something more general out of something that is not general. So, that's actually the best part of the setup, is that it's really simple. So it's just a bit slow. So if it works, I can show you. In a bit while it's loading. So it's just one side. Name of parameter contains this bit, and on the other side this category. Let's see. You can see how simple it is. So this was just for the demonstration. I just so ignore this last bit, but it's just if that's the model name of the control area model, and if it's the name of the control area contains this general bit, then it's included. And on this side, if it's included in the category. So super simple. So.
Thank you, Eirik. You make it sound simple. Thank you.
But it is quite simple.
Yeah. I have another question for, okay, now I'm receiving a lot of questions. I have a question for Morten. Did you perhaps find an option for grouping IFC files when loading them automatically with Autorun, the same way as you can assign a shortcut and discipline, or is that done manually?
No, we can assign a short name, but we can't assign a category. So that's actually one of the features I wish they would include in Autorun. So you have to sort them by short name in that case, and that's not very practical. So we have assigned them categories manually.
Okay, note taken. Thank you. There's a question for Eirik. Were there special volumes included in the IFC files, and was Solibri used for Clash or Revit?
If it's, I'm not sure if I understood. The volumes here, it's a separate Revit file, and it's math objects in Revit, which is exported to an IFC file. If that was answer to the question.
Yeah, thank you. I hope we answered your question. For Henrik, you showed a software tool to check if the wall openings are placed correctly together with laser scanning. Which software did you use?
Software called Immerso, which is pretty brilliant for the task.
Yes, I can also send the link to Immerso to our webinar page on the website. So
you can also see it on the press. Yeah, you can also see it in the presentation, the logo on the pictures. It's recommended.
Yeah. Thank you. Sorry, I'm rushing, but because we're almost out of time. So we have final questions. How do you create the horizontal areas when you are doing it, Eirik?
We do it in Revit. So you go into the mass editor and you draw the. We have drawn it manually in this case. So you just have to set the boundaries, and we have based it on the fire zones, so to say. So that's the main, or the main rule at least, for how it's split up. So, but it's done in Revit, yeah.
Okay, thank you, Eirik. Henrik, there is a question. How much time have you saved, or would you estimate that you have saved going from file-based BCF to a server solution?
That's a good question with no good answer. But if you either ask the question how much frustration you have saved, I will think it's a lot. It's difficult to say, but the point is that if you have control of the BCF issues, and that's the best part of it. So you don't need to ask on back and forth, and it depends also on the complexity of the project. That's part of what I tried to say. There's a lot of people involved, a lot of disciplines, etc., which makes it almost impossible to keep track of the BCF issues without a BCF server. So it's not necessarily to save time, but to have a system to create some sort of control of the chaos.
But you save a lot of time. I don't know how many times I've gone through it and half of the issues are already solved. So then it's just a waste of time. Really.
Yeah. Good point.
And now we can also, we have a Power BI dashboard that can tell me how many issues I have left in each control area. So it's very, very simple to keep control of how much work I have to put in there, for example.
That's great to know. Thank you all. We have some interactive comment from one of the attendees that in the newest Solibri 9.8.12 that you can add categories, which is great to know. Yes, thank you so much for this comment. Do you also use ITO in your process, and could you have some examples?
We haven't set that up, but mostly because we use the checking results, as Eirik showed, to sort out everything in the control area before we do an ITO. So that wouldn't really work with Autorun. We would have to, but we could set up an Autorun where it would open just one IFC. So it would open, for example, only the ventilation model for one building, and then do the ITO from there. You would have to, then all the control area parameters would have to be correct for the results to be correct. But yeah, it is very often correct. So we would get pretty close by doing that. And then after doing the ITO, you can filter a lot in Excel to filter out the control area that you're interested in. So that would work.
Okay, thank you so much, Morten. There were some questions that were not answered, but don't worry, we will add the answer to the website. So we will share the link with you later on. Let me share my screen. Thank you so much, Henrik, Morten, and Eirik. This was really informative, and I'm glad that we overcome the technical problems that we were facing in the beginning. We're having a webinar in 2 weeks. It's a very important webinar regarding fire safety and building a fire-safe future. So we're trying to raise awareness with this subject and talk more about why is it important to integrate fire safety starting from the design. So I hope to see you all in the next webinar on the 6th of April. But thank you so much for our presenters today. It was really great to have you with us, and thank you for our attendees and your nice comments and interaction. So I hope to see you next week. Thank you so much.
All right. Thank you very much.
Bye.
See you.
Thank you. Bye-bye.